Now, there's been some more recent data that was collected as part of another investigation that's just been received within the last week or two. And it's provided a lot more refinement of some of these contour intervals. In general, it's showing us similar overall patterns and distributions, but the concentrations and the local areas where we find higher concentrations is much more refined than what we've got shown here. So, despite all this work, there are still some data gaps. It is a large area, 7 miles by 4 miles. It would be difficult to get one investigation that's going to give us the full understanding of everything happening in the subsurface. So these are some of the data gaps that we still are trying to fill. We want to know what background chemistry is, and we really don't have a very good handle on that. And what is background chemistry? Well, if you could imagine what the groundwater would be like if the mine never existed, then that would be what the background concentrations of chemicals in the groundwater would be. Looking at look real quick about the facilities. If you look at these groundwater flow directions, that gives you a sense of where groundwater is coming from before it gets to the point. To this point, you know, it might have come from back here. The groundwater at one point started here and moved over here over time. So for this point, the background might have been here. That's the background concentration. But if you want to look at it on a more regional basis, you want to start looking at areas that are a little farther away, make sure that they're not impacted by other phenomena. So, oops. So yeah, that's one thing. We don't, ultimately we're not going to be able to fight Mother Nature. Whatever is there in background is going to be there in background. We know that this is a former mining area, and part of the reason it is a former mining area is there's a lot of chemicals of value and interest in the subsurface. So we need to make sure we can separate what was there because just naturally from what was there because of the mining. And that will help us get an understanding of the impact of the mining on domestic wells. One other thing we don't have a good handle on is what's happening between the bedrock water, groundwater, and the groundwater that's in the alluvium. This study focused predominantly on the alluvial aquifer, and it's important to understand what's happening between the two systems. There are some physical and chemical, there's a bunch of mechanisms out there that can affect the way contaminants and chemicals move in the subsurface. Some of those mechanisms will slow down chemical migration, some of them will speed them up, and those are things that we still need to get a better handle on too. And there's other impacts to the groundwater chemistry and flow that we need to have a better understanding of to really fulfill what we call a conceptual site model, an understanding of what's happening in this box. So looking at things like some of these other surface features, the roasted grain, the pit lake, Campbell, ditch, and agricultural influences. Those are things that we need to have a good handle on before we can really move forward and start thinking about how we're going to advance from there. So that kind of brings us to the end of this part of the presentation. It's probably a natural break for questions. So we've got a whole team of folks up here, and feel free to bring anything up now, or maybe you'd like to make it.
Well, I'm just thinking, I mean, you can ask some questions now if it pertains to like this framework. Otherwise, I suggest we go on to the domestic wells portion, because it kind of all fits together in a package, and then you can ask whatever you want afterwards. Does that sound okay to everybody? Okay, thanks.
Okay, thanks. So, yeah, Victor Early is the next presenter. Dave, you're going to come and do the thing next. Okay.
So just to introduce this next portion a little bit, we have been getting a number of questions on domestic wells, and one of the questions was, are there any trends in water quality? Some of the homeowners who receive their well results observe changes in smell, so they call us and ask about it. And so we decided that we would have Victor at the back to look at the body of data that's been collected from domestic wells and analyze it, see if he could determine any trends. Also, just look at how often wells are monitored as an entire set. So he's going to describe what he found, and we're going to talk a little bit about our conclusions based on this study. So, Victor, without further delay. Okay, thank you.
Thank you, Dave. So some of the fundamental questions that we're looking at to try to answer are, where does the domestic water come from? And also, what's in the domestic water? What types of chemicals, what am I drinking? And has the mine site affected my domestic water? That's a really key question I think most of you want to have an answer. So we saw this slide earlier, and it is a cartoon. It's not based on any real data, as Dave mentioned. And basically, it's from the south to the north. It's a cross-section. And it kind of shows the different alluvial zones, the shallow, the intermediate, and the deep. And the groundwater, we know, has been affected by the mine site. And one of the key things that we're looking at is to try to find out how far north the groundwater has been affected by the mine site. So this area is under investigation. And we know that some of the domestic wells have probably been impacted by the mine. Some of them probably haven't. That's under investigation. Some of the domestic wells are screened deep. Some of them are screened shallow, but the bulk of them are screened or draw their water from the intermediate zone. And that's typically from about 100 to 200 feet below ground. Okay, so what's in the drinking water? Well, it's kind of dependent upon the geologic conditions and what's in the geologic materials. And in general, in the western states, and in particular Nevada, it typically has these metals in it. And I've highlighted a couple of them that we know are related to the mine site: arsenic, copper, and uranium, as well as sulfate, if that's not listed here. So there's a whole list of different metals that can be found in your water. But again, with the mine site, with the arsenic, copper, and uranium are the primary contaminants. So the EPA has come up with drinking water standards for drinking water. And these standards are called maximum contaminant levels. And they're easy to find online. If you just type in EPA, MCL, do a search, they'll all come up. And the levels for uranium are 30 micrograms per liter, and for arsenic it's 10. So if your concentration in your well is 30 or below, it's considered safe to drink. And for arsenic, if it's 10 or below, it's also considered safe to drink. So the domestic well sampling program was started by ARC back in 2003. And they focused on the wells north of the mine site, because we knew that the groundwater generally flows from the mine site to the north and northwest. And the sampling was pretty frequent for the first part of the program. Most of the wells that were targeted were sampled up to 5 times within a year. And that was in 2004, 2005. And since then, ARC has sampled a subset of those wells once a year. And if the results come back with uranium concentrations of 25 micrograms per liter or higher, ARC has offered bottled water to be used. This is a chart that shows how many times the individual wells were sampled between 2003 to 2009. And basically it shows that the first bar shows that there were about 32 wells that have only been sampled one time during that period. So the bulk of the wells were sampled up to 5 times. And there's only a handful of wells that have been sampled